Okay, well this is a circuit I made, thermostat circuit for electronic system implementation subject, semester 2, 2010. As you can see, we have a wheatstone bridge which measures the resistance of the thermistor, this blue thingy here, and this measurement in terms of the voltage across the wheatstone bridge is passed through a basic instrumentation amplifier type circuit with unity gain, hence no second stage, and the output of those this amplifier is passed through to the Arduino, these two inputs here in the center of the picture, and Arduino takes measurements of these voltages and converts them to a resistance, which is the resistance of the thermistor, and then to a temperature using a thermistor equation, an empirical equation that you can calculate. So this temperature reading is then fed through a displayed on the LCD here. It's a bit hard to see, but you can see currently it's about 22 degrees. And it's also displayed on the computer screen, which you can't see here, but it's the same thing. So this temperature is used as feedback into back into the Arduino. Well, the Arduino knows about it, this temperature value, and it's used to control this temperature value is used to control this transistor, which is the blob you see there. It's basically a transistor which is being blue tacked onto the thermistor, and the transistor is basically, you can think of it as a heating element that will have a fairly reasonably high current passing through it, 20 milliamps or so. That's supposed to heat up the thermistor, increasing its temperature. And by using this mechanism, what happens is you specify a on and off temperature you want to maintain the thermistor at, and if it's too low, the transistor circuit will go on heating up the thermistor, and until it reaches that turn off temperature, and once it goes above that turn off temperature, the circuit switches off, the transistor circuit, and the thermistor is allowed to cool until it drops below the on temperature, in which case the transistor circuit switches back on again. So I've set the temperature of the control temperatures between 22.5 and 23.5 degrees. So have a look right now. The temperature is 22.06, and you can see that the LED is on, which means that the circuit is heating up. And unfortunately, I think this battery which supplies the wheatstone bridge and the transistor circuit doesn't have enough charge in it to supply the current required, so the heating is it's not powerful enough to heat up the thermistor, but it was working before. So okay, as you can see here, the temperature of the thermistor is about 21 degrees at the moment. I have modified the Arduino code to set the off temperature as 21.5 degrees and the on temperature as 21 degrees. So you see that currently, because the temperature is below 21.5, the LED is on, indicating that the transistor circuit is switched on and heating up the thermistor. So we see that the temperature is 21.3, 21 going up, 21.4. The heating effect is fairly, it's a fairly small heating effect because of the low current that the battery can supply. So the heating would be fairly slow. You can see it's gone above 21.5 now, and the LED is off, and it's allowed to fluctuate freely between 21.5 and 21. If it's between those ranges, the transistor circuit won't switch on again until the temperature drops back below 21, which it's slowly doing. The blue tack providing some thermal insulation there. So it's nearly there, 21, boom. So we see that the LED has turned on again. There is some current flow in the circuit, which can be measured in the multimeter that I've connected via these crocodile clips, and it's about 16.5 milliamps. So you see it's heating up now. Not much of a heating effect. It's quite slow, but it'll get there. So, oh yeah, by the way, this circuit is a simple bang bang thermostat, the simplest type. So it's just on and off. 32. It's very slow heating effect. Ah, there we go, nearly there. One more. 49. Come on. Right, now you see the LED is switched off. So the room temperature is probably a little bit around about 20 degrees, I'd say. So this transistor circuit is really not supplying that much power. So there we go. That's the simple bang bang thermostat circuit for my ESI subject, which I need to write a logbook about. Here's the same circuit, but I have managed to get the backlight on the LCD to work. So you can see it looks much nicer now. You can see it much better. All I needed actually was to connect a 5 volt and the ground to the last two pins shown here, pins 15 and 16, and yeah, it just turn on the backlight on the LCD. That's how simple it was. You can see the heating of the transistor circuit is still turned on, but the LED is off, I think, because there's not enough charge in the battery. Well, it's still trying to heat it up, but there's not enough heat. Otherwise, the circuit is the same. I just wanted to show the backlight because it looks nice. Anyway,